Okay, so you got this differential equation, and your teacher says you have to solve it using Laplace's method. Well, using Laplace transformation. So that's what we're going to do. And yeah, let's start just by taking the Laplace of each of these things. I like to break it up because if I don't, I'll mess it up. So I have to break it up. So 3 Laplace of y triple prime. Okay, we'll start with that one. So that's going to be 3. And then I'm going to pop up my formula sheet real quick and show you the answer. Here it is. So it'd be right here. And I'll link the sheet. I'll link something like this sheet in the description. Okay, so it's going to be s cubed big Y minus s squared little y of 0 minus s y prime of 0 minus y double prime of 0. Okay. So this is like the general idea is you look for your sheet, right? You just look for things in your sheet. So this is going to be 3. Then now we're going to fill in these with this stuff. Okay, so it's s cubed, big Y stays the same, minus s squared. Now what is y of 0? Y of 0 is 0. So we can erase that s squared. So this whole thing will just be 0. Y prime of 0 is 1. So it's just going to be minus s. Then minus y double prime is minus 1, so plus 1. Okay. And what is that? That's going to be 3s. That's going to be 3s cubed minus 3s plus 3. Okay. We're going to do the same thing for this one now. Okay, so 5 Laplace of y double prime is going to be 5. It's going to be something similar, s squared, big Y, s, y of 0, minus y prime 0. Now we can check the table to see if I got it correct. S squared, big Y, s, little y of 0, minus y prime 0. In their case, they're using y instead of f. I mean, f instead of y. We're using y. Okay. So it's going to be 5, and now we're going to fill in what this stuff is, just like we did, so that's going to stay the same. How about this one? Okay, y of 0, it's 0. How about this right here? That's going to be negative, negative. Oh, it's this one, it's 1, so minus 1. Okay, and we'll simplify it. 5 s squared big Y minus 5. Okay. And let's do this one. So, that'll just be the Laplace of y prime, which is s big Y minus y of 0. And that will just be, what will that be? That'll be s big Y, y of 0 is 0. And we're going to check our sheet if I got this thing correct. Yeah. Okay. So we got one more thing to do. I'll do it right here. So it's going to be the Laplace of negative 1 with y, which just turns into negative big Y. Okay. So with all this information, this is everything on the left-hand side once we do the Laplace transformation. We're going to add it up right here on this line. Okay, so let's do that. So it's going to be 3s cubed. 1 second. I realize I made a minor mistake. Hopefully you can comment and say that you saw it. 3 big Y, right? There's big Y here. Just randomly disappeared, but yes, it's there. It's going to be 3 big Y minus 3s plus 3, then plus this, plus 5 s squared big Y minus 5, then plus this, and then plus this. And if this is correct, if we did this correct, it should look like the auxiliary equation to this. Oh my god, I'm low energy tonight. So let's simplify this. Let's factor out all the big Y's. Big Y, 3s3, and then plus 5s squared, and then plus, oh, sorry, one second. See, this is why it's very important to break in parts, because as you guys can see, I wrote a -4. It should be this thing turned into a -4. So remember, guys, like, it's important to keep your book tight, because if you mess up this part, like, it's so easy to mess this thing up because this transformation takes a while and there's a lot of things. Try to keep your handwriting clean, or else you can screw everything up. The -1. Okay, so I factored out all these guys. So there's a -1 here, there's a 5s squared here, and there's a 3s cubed here. So look, 3s, 5s squared, y prime, that, and then, yeah, so it should resemble this, right? And I also forgot the s there. Okay, good. You want to catch all these little mistakes right before. Plus s, and then minus big Y. Okay, so right, if we're to write out the auxiliary equation for this, as if we're going to do like method of undetermined coefficients, right, if we were to do that type of thing, the auxiliary equation would look exactly like this, right? It would look something like this. Look, I messed up it again. It's -1. Right, we would write it as like m3m cubed plus 5m squared plus m minus 1, where this is a polynomial that represents the differential equation, right? So that's how you can check that's correct. And it's an important check to make, because as you can see, I've messed up like a few times already. Just on like there's so much information here, so just, okay, I'm going to keep preaching, just take your time. Okay. So nonetheless, this is just everything with that. Like, we're not done. We still have these guys over here. We have this over here too. So it's going to be minus 3s plus 3, and plus 3 minus 5. We'll do that at the same time, so we'll write it as plus 2. Oh, 3. Oh my god. Yeah, -5 plus 3 is -2. And there's a 3s here. Okay, so that looks like that's all the singles we got. As in, singles is, they don't have this attached to them. Okay, so then what is this? This is equal to the right-hand side. Alright, we didn't take the Laplace of the right-hand side, so we should. So we say the Laplace of 0, and that's just 0, right? We're lucky because it's just 0. So, nonetheless, we could write our equation like this. 3s cubed plus 5s squared plus s minus 1. And then I'm going to, since it's equal to 0, since this right-hand side is equal to 0, I'm going to put these guys on the other side. It's going to be 3s plus 2. And I want this big Y by itself. Why do I want it by itself? Well, that's because I want it by itself because look at this right here. Like, look at this kind of relationship. So if we take the Laplace of y and we get big Y, then we know that y is equal to the inverse Laplace of big Y. So this would be our solution, right? Unfortunately, it's not as simple as just to write this. I wish it was. This guy represents all of this crap, so yeah, we need to do that. Okay, so let's write that. So the big Y by itself, if we isolate it for itself, it's going to be 3s plus 2, all divided by 3s cubed plus 5s squared plus s minus 1. Okay, so as you can see, we're going to do some partial fraction decomposition here. Okay, so what can we do real quick? Is there some sort of way we can factor this to make it a little bit nicer? I'm not gonna lie, this part is like really hard to do in my opinion. If you think it's easy, you can go fuck yourself. but this part here is really hard, so I'm just going to show you guys the answer from alpha, how they do it. So what do? You use rational root theorem to get to this part, and then after that, I mean, here I'll show you. Like, this is the partial fraction expansion. Oh my god. Like look at this. I mean, this is the partial fraction expansion. So yeah, we're just going to jump to this. I just wanted to show you guys the algebra here. I mean, I don't think your teacher would ever put something like this on the test. This is from some random textbook, but yeah. Okay, so now we're going to take the Laplace of each of these partial fractions. Okay. So take the inverse Laplace. And actually, real quick, let's just start with these two. It'll be the easiest. And then we'll do that one in a second. So let's factor out the negative 9 real quick. Let's factor out the negative 9 over 16. Then we'll take the inverse Laplace of 1 over s plus 1. Then we know that to be negative 9 over 16 e to the negative t. And let's check our table. Okay, so I believe it's exponential formula. So yes, it'd be since they have a minus a here, for us it was a plus, so it'd be a double minus. Right, that should make sense. Okay, we gotta do another Laplace transformation. Inverse Laplace transformation, and we'll do it for 1 over 4. Laplace inverse of 1 s plus 1 squared. And then again, so what you do, you look at the table, and you think, what matches here? Okay. This one looks like it matches, where n in our case is 0. Okay. So n in our case, let me maybe zoom in for you guys. Damn it. Okay, n for our case, where is it? N for us is 0 because n for us is 1 because it's s plus 1 squared. So n is 1, and then n factorial, it's going to be 1 factorial, which is 1. Okay, so it's going to be 1/4. And the formula went something like this. Sorry, I already forgot it. It's going to be t to the n. So t to the n for us is just 1. And then it's going to be e to the negative t. Okay, that part is done. Okay, now take the inverse Laplace of this guy. But if you looked at the table, there's not really anything that will make this easy because there's a 3 right here, so we got to do some algebra first. We'll do this part in green, so 27 over 16, 3s minus 1. So we got to divide by 3. Okay, so, yeah, I'm at this point right now where I'm fucking up dividing things by 3. Okay, 27 divided by, so we're going to divide the top and the bottom by 3, because that's how it's equal to each other. 27 divided by 3 is 9. Okay, and then we're going to pull the 3 out. So we're going to divide the bottom by 3, so it's going to be s minus 1 over 3. Okay. It's not going to be 16 over 3 in this case. Like, don't do 16 over 3. It's s minus 1 over 3. Right, because it's like, if this thing was times in there, and then you divide it by 3, this is what you'd get when you factor out the 16. Okay, so you have to make sense of this. I know it kind of looks funky. At least to me it did. Okay, now we can take the inverse Laplace of this. So 9 over 16, and then we'll take the inverse Laplace of 1 over s minus 1 over 3. This will be 9 over 16. And it's going to be the same formula that we used here. So in this case, it'll be e to the what? T over 3. Okay, so all that's very useful, all that's very helpful. And now we can write our answer. So we can write our answer as y. Y is what? Y is this guy, and this guy added all up. Okay, so maybe we'll start with this one. Negative 9 over 16 e to the negative t plus 9 over 16 e to the t over 3 plus t over 4 e to the negative t. So that's your answer. I mean, that was a lot of work, and I literally cheated by using Wolfram Alpha because I couldn't do the algebra for that part. So, but it's still so much work. I mean, look at it, it just filled up.